Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. So we continue talking about our variable record length files, and in the last video we got to the point where we had an apply and a length that we felt good about, but we still didn't have the update. And we can talk through what needs to happen in update a little bit. We kind of drew out here the problem with update. One of the things that we have to do is, okay, some of these aren't necessarily linear. You can do them whatever order you want. Determine updated size. Read the current location and size. If determine new location, and that's based upon whether the current size and the updated size, whether the update fits in the old size, and then write data at location update index entry. Okay, so that's kind of an outline of what we need to do. This first one, well, how should we go about doing that? It would be possible to make it so that our student had the ability to estimate how much space it was going to take, and it's not too bad. It's 2 ints plus however many chars. But it turns out there's kind of a nicer way for us to do that, where we can write stuff out using whatever the normal serialization is, not put the burden on here, because this would get harder if, for example, this student had courses, and then the courses would have their own sizes, and things would be a bit more challenging. What we can do is if we go to the API, there is another type in the Java API that's in Java I/O, and it's back in the stream. It's called a byte array output stream. And we can create one of these, and if we don't give it a size, it just sets things up for us, and we write to it the same way that we would write to any other stream, which in this case we're going to want to wrap it inside of a data output stream so that we can pass it to our writer. And then it has the ability to call toByteArray and give us an array of bytes. And that array of bytes is going to be how much data this actually takes up whenever we write things out. So let's go ahead and let's write some code for that. So that was a byte array output stream. And I'm not going to pass it anything there. I need to import that. And then I need a data output stream that is wrapped around that byte array output stream. Okay. And now I need to call the writer that we have up here, and we pass it that output stream as well as the object that we want to write, elem. So I pass it DOS and elem, and that will go about doing the writing this out not to the file but to an array of bytes, and this class here will make sure that the array of bytes grows as is needed. So now we can find out what that array of bytes is, the buffer, by calling toByteArray. And so now we have access to that. So this is not only have we determined the updated size, in addition, because that's buff.length, we've also gotten it packed into some bytes, and we can use that again later when we write it out down here. Okay, so now that we have that, let's go ahead And let's seek in our index file. So index file dot seek to idx times 12, because as we spoke about in the last video, we have a long and an int as kind of our record for the index file. We can make the position equal to index file dot read long, and the length of the data as it is right now is index file dot read int. Okay, I'll go ahead and put some parentheses there. So now we know where the data for this had been stored in the file, and we can now use that to determine the new location. So I'm going to say okay, the new position and the new length is equal to, well, this depends upon a number of things. One of which is, what if the index that we're updating is outside of the range of what's in the file? So if idx is greater than or equal to length, well, then it simply goes at the end of the file. So the position that we're going to return is data file dot length, and the size is our buffer dot length. So in other words, if we write a new record and it's at an index that doesn't exist yet, we're just going to stick it at the end of the data file and make it however big this data wrote out to file. Okay, what if that's not the case? What if we're overwriting an existing record? Well, then we know these two values, and in fact there's a part of me that's thinking I could stick that code and put it down in here. Yeah, in fact that's probably a good idea, because there's no point in doing that if we're out beyond the end of the file. Okay, so I have the position and the length that this record is in the current file. I need to check. I have two possibilities. Is that length greater than or equal to the length of my buffer? Because if that's the case, I can write it out exactly where it was. And I use the length that it was written out to originally, not the length of the shorter buffer. I'm fine leaving that empty space, and then if they update again and it gets big, but not bigger than the original length, we can still keep putting it in that location. However, if what we need is bigger than that, then I basically go to this case here, where now it has to go at the end of the data file, and I should make it as big, however big the buffer is. So that gives me my new position and my new length. Now I can write that out. I can do on the data file, I can do a seek to the new position, and then I can do a write. And now I could call writer and do this, but writer might be doing a lot of work. I've already put it together as a byte array, so I can just call write and write out buff. In addition to that, I can take my index file and I can seek to the proper location in there, and then index file dot write long of the new position, and write int of the new length. And there we go. This is the update method for our variable record length file. We could come into here and instead of playing with a particle, we could make a students.bin and as students, I might go with data.bin extras student since we name things the same, it's fairly easy to update that. And the student needs a name and an ID. We'll build another student. And now we can iterate through. Let's call this just S. So we'll print out their name and their ID. We already illustrated that the math does not give us back the same values. We can call run, and here we go. Okay, note that this isn't as simple as it's just sticking these things in some location in memory and then it's pulling them back out. When we do the apply, we're actually jumping into locations in the file. Granted, this doesn't actually do any updating. We're not doing a very fully complete test here of making sure that we that all of these functions work, but we've illustrated the key points of our of what we wanted to write, and it will remains as an exercise for the viewer to write more. The textbook also has more complete tests of a collection that is very much like this. So that's it for this video. In the next video, we're going to talk about how we could write a linked list out into our file.